Good day to you. This is teacher Leland, Alejandro, and we're going to do angle relationships this discussion. We shall try to see immediately the examples, and we will learn through the examples from the problem set. All right, let's start with the first number. Okay, and let's have the instruction. Name the relationship complementary angles, linear pair, vertical, adjacent, alternate interior angles, corresponding angles, or alternate exterior angles. Now, if you were able to read the note that I sent in the Google class, then you were able to see at least the definitions of this. Now, I'm going to do some explanation as we go along. The first example is an example of vertical angle pair, okay? And the definition is the vertical angle pair is actually formed by two intersecting lines, and they are non-adjacent. And this is actually a vertical angle pair. So try to remember the drawing, okay? Try to remember the drawing. So this goes to the first number. All right, here comes the next. This is number 2. You're presented with two parallel lines here, two parallel, because you can see the symbol. And these are the parallel lines, and this line that intersects the two is called a transversal. Now, the angle A and the angle B, let's do a little annotation there. This angle and this angle, corresponding angles, okay? Corresponding. And the definition of corresponding angle pair is one interior and one exterior, okay? This angle is bounded by the two lines. So it is interior. And then the angle B is outside the two lines. And that is the exterior. So the definition of corresponding angle pair, two angles on the same side of the transversal, okay? This is your transversal. This is your transversal, this line, and the two angles are on the same side, one interior and one exterior. And you call this corresponding angle pair, okay? This is what you call this angle pair. So you shall be able to check on the answer. This is called corresponding there, corresponding angle pair. All right, so that goes to our second number. Let's continue with number 3. All right, here's number 3. Again, we are presented with diagram with two parallel lines because of this symbol here. Two parallel lines and a transversal which intersects the two lines at two different points. Now, the angle A is outside the two lines, and also angle B, and they are in opposite based on the transversal. It's A on one side and B on the other side. Okay, you call this alternate exterior. Alternate exterior angles. So you can see the two angles are on different side of this line, different side, and they are both exterior. So you call this alternate. That's why in a different side of the transversal. So you call this alternate exterior angle. Okay, let's continue with the next number. Okay, here's an example of an adjacent angle pair. An adjacent angle pair is formed by 3 rays, and they share one common side. They have a common side, a common vertex, and non-overlapping interior points. These are the interior points of the two angles, and they are not overlapping. They are sharing one common side, one common vertex, and they don't have overlapping interior. So what is this overlapping interior points? Well, if you can see a drawing like this, uh, let me just do it correctly. All right. If you have something like this, and this is AOB there, then you can see overlapping interior points here. Let's say AOC, and this is, let's say we put here D there. If you can see their angle AOD and BOC, they have interior points here. They have interior points here, and they're overlapping. So if you can see there are two angles AOD and angle BOC, they have common interior points that are overlapping. And you cannot say this is an adjacent angle pair. Okay, so the definition of adjacent angle pair, they share a common side, they share a common vertex. Vertex is the connection of the rays here. And that's the common point. You call that vertex. But they should not have an overlapping interior point. So what we have here in our drawing is not adjacent. But this one is adjacent. They have a common side, common vertex, and non-overlapping interior points. So the answer here is adjacent. And we shall be able to see that adjacent angle pair. All right, so you should be able to check on this. You should be able to learn at least its definition. That'll be for number 4. Let's continue with the next one. All right, let's have the next check on the next one. Let me clear the answer. Let me proceed to the next. All right, here's another adjacent. Okay, you can see exactly like, only it's slightly twisted. Okay, you can see a common side and common vertex, the common point of the 3 rays, and they share a common side, and they don't have common overlapping interior points. So this is also adjacent. Okay, there's the answer. Next is number 6. Okay, all right, we already discussed this a while ago. Okay, 2 angles on the same side of the transversal. You see, A and B is on one side of the transversal, this line, and one interior and one exterior. You call this corresponding, and that should be it. Corresponding angle pair. Okay, that goes to our number 6. Let's have number 7. What do you call this? Vertical angles. Okay, formed by 2 intersecting lines, and they are non-adjacent. You call this vertical angle pair. There. Okay. All right. So that's it. This is the same as the first number. Let's proceed to number 8. All right. Here's another corresponding. Okay. You can see 2 angles on the same side of that transversal line. Same side, one interior, one exterior. You call this corresponding. There. Next, number 9. All right. Number 9 is, all right, we can see 2 angles on different sides of the transversal. This is your transversal. Okay. And B is on one side, A is on one side. Now, they are both exterior. Okay. They belong to the outside angles. Speaking of the 2 lines, okay, these are the angles outside, okay? So these are called exterior angles, and they are an alternating side of the transversal. So you call this alternate exterior, okay? That should be the name. Well, you have to know the names of this, because in computation, you'll be needing its meanings. Okay, so this is what you call alternate exterior. All right, that's it for number 9. Let's have number 10. Adjacent. Okay, we already discussed this. Adjacent. All right, adjacent. Next. Okay, here's another adjacent angle pair, but this one has more characteristic. The sum of the 2 angles is 90, exactly 90. And when you have adjacent angle pair like this, and the total is 90, you don't call it adjacent, and usually you will have to call it complementary. Complementary angle pair. There, complementary. Now, complementary angle pair is not necessarily adjacent. It can be separated. Only the total is 90. So if you have a 30 in this position and another over there, 60, these angles are still called a complementary angle pair. Okay, so that goes to our complementary angle pair definition. Let's continue with the 12. All right, we don't have to define it again, okay? You just have to be familiar with the figure. This is alternate exterior. Alternate exterior there. All right, let's continue with 13. Again, we don't define it anymore. We already know that. That's alternate exterior angle. Next, we don't have to define again. This is an adjacent angle pair. Adjacent angle pair. Next. All right. This, what we call adjacent, but the total is 90, and there's a special name for this. We call this complementary. Complementary angle pair. There. Next. Complementary again. You can see the symbol, the red symbol, that means right angle, and all right angles measure 90 degrees. And when the total of A and B is 90, that means they are complementary angle pair. There. Next, number 17, corresponding, okay? Two angles on the same side of the transversal, one interior, one exterior. So you call this corresponding angle pair. Next, number 18. All right, you have two angles inside these two lines. This is on one side of this line, and this is on the other side. And they're alternate, okay? Alternate interior. Interior, okay? So that will be alternate interior. All right, so that goes to our 18. Alternate interior, if you did not see it. Number 19. All right, number 19. This is again two angles on different sides of this transversal, and they are both interior. So you call this alternate interior angle pair. There. And so we continue with the 20th. Alternate interior again, because they are two angles on different sides of the transversal, and they are both interior. So this must be alternate interior. Next, vertical angles. Next, alternate exterior. Okay, there. Next, alternate interior. Okay, there. Next, sharing common side, sharing common vertex. Okay, they don't have overlapping interior points. Adjacent. Adjacent angle pair. Next. Okay, two angles on different sides of the transversal, and they're both exterior. Okay, so alternate exterior there. Next, alternate exterior again. Okay, alternate exterior. Two angles that are exterior on different sides of the transversal. Okay, exterior if the angles are here or here. Okay, so just remember exterior angles. Okay, angles that are outside the two lines. Okay, that are called exterior. So these are exterior angles, and they're positioned on different side of the transversal line. So we call it alternate exterior. So this is alternate exterior. Next. All right, this is something new. All right, it looks like adjacent. They are, okay? The angle A and angle B are adjacent. Only the two non-common sides are opposite rays, and they form a straight line there. and this is now called linear pair. Okay, linear pair. A linear pair forms two angles whose sum is 180. Okay, and they are supplementary angles. That's the other name for this pair. Okay, but the only choice we have here is the two words linear pair. So this is called linear pair, and be able to differentiate this from adjacent. Okay, this is a special adjacent. You can call this adjacent. Okay, you can call this adjacent, but a more specific name for this is linear pair. Linear pair. All right, so that's it there. All right. Okay, so next, this is again something that forms a straight line. Okay, looking at the two non-common sides, all right, of this adjacent, all right, but you don't call this adjacent because the non-common side forms a line. Again, this is linear pair. Yeah. Okay, next. We know this already, alternate interior angles. Alternate interior angles. 30 alternate exterior, and 31 is corresponding. I was able to reveal the answer, but it's okay. All right. Corresponding angles. All right. So the two angles are on both on one side. Both of them are on one side of this line, and one interior and one exterior. So you call that corresponding. Let me click the reveal answer key so I can remove it there, and then proceed to 32. I think this is up to 36. So, all right, looking at number 32, this is only alternate exterior, alternate exterior. There. I hope at this point you already mastered the diagrams, okay, the diagrams. Let's have 33. Okay, here's again alternate exterior, okay. Just remember the definition, okay. Two angles on different sides of the transversal, and they are both exterior. And this is called alternate exterior. All right. Next. Okay, you can see the right angle symbol there. Okay, that means the total of the two angles is 90. You call this complementary. Okay, complementary. Next, this looks like adjacent. They are, but the two non-common sides form a straight line. You call this linear pair. There, linear pair. So I hope you can differentiate a simple ordinary adjacent from a linear pair. It's a special adjacent angle pair, and you call this linear pair. Okay, and the last number is another linear pair. All right, that's it, linear pair. There. All right, so that's it. I think there's no more 37. All right, no more 37. I hope you were able to learn the definition of this, and we shall use this in the next lesson in the computation. And this will be all for now. Bye-bye.